Good afternoon, Dr. Francis.
Yeah, good afternoon. How are you?
Hi, thank you, sir.
All right, now we set.
Yes. Good afternoon, Dr. Okoye.
Hey, good afternoon. Good afternoon, everyone. I hope you can all hear me clearly.
Yes, we can.
Yes, sir.
Doctor.
Okay. What did you guys do last week? What did you do last week? Know where I will start from.
So last week was more like an introduction, and there were a couple of things that that were said. That there was an explanation as to what machine learning is and the various kind of there was a word he used, I can't remember it, but then he still talked about like the roadmap to for machine learning, talked about defining the problem, then preparing the data and evaluating algorithms, then the results and all. And then he went, there was a calculation that was done during the course of the session last week. And I think that's where we stopped, and then it became complicated as far as algorithms and all those.
With the algorithms, right?
Yes, sir.
Okay, okay, let's go with that, right? But please, just a little one for those who are new. Just sit down, relax, and enjoy the whole movie. Okay. And just try and just get the part that you can get. Any other one, just leave it for Chino and the rest. All right, so let's start from the one we already know. So as data analyst, what do you do as a data analyst? What do you do as a data analyst? Yes. What do you do as a major task as data analyst?
So what did you say?
So what do you do as data analyst? What are the major tasks as a data analyst?
Okay, is it the extract, analyze and visualize?
Exactly. So you extract, you extract your data. What do you do next?
You analyze.
You analyze, right? So analysis implies that what you will clean and transform that data into.
Yeah.
You now what visualize. So this is normally what we would have done, right? So we have learned tools like SQL at this point. We have learned tools like Excel at this point, your Excel, your pivot tables, and the rest. Probably here we will have done a bit of Python. Yeah, to analyze the data. Then here tools such as Power BI. Have we done Power BI?
Yeah, we have.
Okay, we have done Power BI. So this is where you stop as a data analyst most times, right? So now at this point, we're now going beyond the data analysis role, right? We're not going into another realm. That realm is what? Data science. So this is where data science job now starts. Can you see that? So beyond all this, data scientists can also do all this, but beyond this, is going to also what? Build what? Models. Right? He's going to build what? Models. And again, he's going to also what? Deploy the models. Okay. So for example, when you look at your Netflix, when you watch a movie, when you watch a horror movie like this one, after you are done with the horror movie, you now want to predict from it, you know, that since you watch this horror movie, you know, most likely you are going to like this horror movie. It's going to what predict, isn't it? So they have already embedded a model at the back end of it. Can you see that? So that model uses what they call an algorithm. Okay, it's called what? An algorithm. And what's it about? It's about what? Pattern recognition. Do we get that? It's about pattern recognition. Okay. So once we have got the pattern based on the algorithm, we will now what? Deploy it live. So that's why even when you're on Jumia or you're on Amazon, you buy one or two items, it will now predict for you that, oh, based on this, people who bought this also bought this. You know, so it's predicting its form of what a recommendation system. All right. So all you need to understand is that at this point, we are going to the realm of what data, what science, which means it's a bit deeper than what you have been doing before. So that's why you see, as for data analytics, there are 4 levels of data analytics. What are the 4 levels of data analytics? What are the 4 levels of data analytics? What are the 4 levels of data analytics? Yes? What are the 4 levels of data analytics?
Diagnostic.
Yes, but before diagnostic, now we'll do what?
There's descriptive.
Descriptive, you know, so descriptive analytics. Sorry, not aligning it right. Descriptive. After descriptive, that means what has happened, you know. So the next one is what?
The
Diagnostic.
diagnostic.
Why has it happened? Then what's the next one?
Predictive.
Predictive. After predictive, what's the next one?
Prescriptive.
Prescriptive. Now, up to this point, this is what data analysis is focused on. Can you see that? This is what the data analysis is focused on. What has happened and why did it happen? Can you see that? Now, data scientists now are more focused on these aspects. You now predict. So they predict using what algorithms based on the pattern, you know, to determine what the patterns. I hope that is clear. So it's based on that they now want to deploy it. So when they deploy it in terms of either they write they build a website or a mobile application. A mobile app. Can you see that? So that's why almost tools now they will tend to try to integrate maybe something like ChatGPT and AI into it. That's the deployment stage. But the back end of it is about pattern recognition based on what an algorithm, which is based on the model they have built. I hope you understand the flow now. Do you understand this flow now?
Yes.
Okay, good.
Yes, sir.
All right. So that's why this is where we are now focused on this aspect of it. Okay. And in doing this, I think I probably will just go a bit to the foundation. Go a bit to the foundation. Okay, I'm sure he has explained the concept of machine learning, right? He has explained the concept of machine
Yes,
learning.
sir.
So you see that machine learning is actually the backbone of data science, right? is the backbone of what data science. But you see, for you to deal with this, understand machine learning, you must have basic understanding of what statistics. Okay, you must have basic understanding of what statistics. Not deep per se, but it will be a bit higher than the way you're doing. You know, in normal data analytics, we're stopping at mean, median, mode, standard deviation. You know, now, for data science part, you go a bit further. Like you talk about normal to check for outliers. Did you discuss anything about outliers?
Yes, we did.
We discussed something about outliers. Did you talk about how to treat the outliers?
Oh, he did talk about detecting the outliers.
Okay. Okay, probably maybe next week we can look at that a bit. But I'll just explain. Now, so you need to understand outliers and how to treat them, right? So these are now the bits more advanced things than what you have been doing before. Okay. And that one again, you need to understand the concept of correlation, you need to understand the concept of regression. All right. Because at the heart of everything you are doing in machine learning is about understanding relationship and trying to make predictions. All right. And how do you make the predictions? You are using what? Regression analysis. So anything where you hear algorithm, the foundation is what? Your regression analysis. That's the foundation of everything. So as the condition now evolves, that's how the algorithm will also what evolve. Okay? But you must understand how regression works. I think for those who are new, I'm sure maybe only a few of us. I'm sure we have heard of regression, but do you understand what regression is? Because that's the heart of everything we are doing in machine learning, is regression analysis. Okay. Only now they will now call them algorithms. So they now give different types of algorithms, but actually it was regression. And regression is about what? Pattern recognition. Okay. It's about pattern recognition. I hope that's clear. Now, under your machine learning, so machine learning is just simply about what pattern, what recognition, right? And basically, when you say it's learning, what does it mean? When you say it's learning, how do you learn? Normally, how do you learn? As a human being, how do you learn?
You read.
You read, you know, that means you are getting data, right? So that's input. Then output is what comes out of you, isn't it? So there's an input, there's an output. Okay. So when you say machine learning is the same way. That means you are not using the computer to learn. Okay. But as human beings, we learn that through reading, yes, through knowledge, or mostly through experience. Okay. But for computers, how do they learn? They learn through what? Data. So data is the experience they are saying, okay, I've seen this pattern before. I have seen this pattern before. Based on this pattern, I think it's likely going to be this. That is why whenever there's any prediction, it's a chance, so likelihood is never exact. Okay? So that's why when you are trying to do your predictions, there's a chance. You can never be 100% accurate. So that's why you normally will check what the accuracy level. Okay? There's usually what accuracy, what level. Did you guys talk about overfitting, underfitting? Did you talk about overfitting, underfitting? Did you guys talk about overfitting and underfitting?
I can't remember, but I know we talked about feature scaling also. That was where we had normalization and standardization.
Okay, feature scaling, standardization. Okay. Now, you see, when you say overfitting and underfitting, now imagine now you are going for an exam, right? For you to pass an exam, you need to read, now, is it not? So you now saw a past question. You now cram the entire past question. You know all the answers by heart. Can you see that? So anytime they ask you anything inside that past question, you can just give them the answer because you have seen it before. Is that not? So when they now give you a test, you maybe get maybe 90% or 80%, right? 90%, 80%. We not say that person is very smart or that person is very intelligent. We not say that person is intelligent.
Yes.
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 Intelligent now. You now ask the person, what is 3 plus 5? He has been getting all the complex ones, so because he has seen it before. But you're not asking one simple one that because 3 plus 5, you expect that someone who has been getting everything should get that simple one, is it not? Then he now feels it. Can you see that? He now what feels that? He now say 3 plus 5 is 7. Will you not be surprised that somebody will feel that one? If he has been getting 80%, the tough ones, he has been getting all of them, but that simple one, he has not failed it because he has not seen it before. Can you see that? So that model is tend to be what? Overfitting. Can you see that? That's what overfitting. Underfitting means that all the past questions he read, if you ask him, he doesn't really get it very well. But when you now ask him something else that is not there, he's getting it. That is what underfitting. So which means the model, based on the past data, it doesn't really sit on that, it doesn't really predict it very well. But if you give it any other one, it predicts it what correctly. So it says underfitting and what overfitting. So our objective is to have what a balance. So it should not be too overfitted and should not be what underfitted. Just have what a balance. That's the objective because you want to be as accurate as possible. And that is why when there was COVID, right? When there was COVID, you know, when they brought out that vaccine, what was the rate, confidence level on that, the potency of the vaccine? What was the rate? What was the rate?
Like figure-wise?
Yes, figure-wise. I think the Pfizer gave us a rate there. In Pfizer gave us a rate there. It was about, I think, 84% or so, right? Now, can you rely on that? 84%. Will you be very confident in that?
For medicine, no.
Yes. For medicine, will you be confident with that?
No.
Exactly. Right? So what will you expect at least?
99.9.
At least 99%. You know, because you can never be 100%. Right? So that's why you see, the higher the accuracy, the better. Right? The higher the accuracy level, the better. So 88%, what does it imply? That means if I give 100 people, right? 20 people may likely not survive. We want to take that risk.
Nope.
Nope.
So for medicine, it's a bit much more sensitive. Can you see that? Than other, like in business and others. So in business and the rest, our own level of confidence is about what? 95. Can you see that? About what? 95 confidence level. So when you are doing your accuracy level, so sometimes the higher it is, the better, but it now depends on what your threshold is going to be. All right? It depends on what your threshold is going to be. So that's why you now bring in as many features as possible, right? As many models as possible to try and now see which is the best. So let me try and explain what that model is. So can we go to regression to explain it? Can we explain the regression model? So what is simply doing there? What you are simply doing there? You first of all have the data. Your data is like the input, right? The data is the input. You now apply it through what? An algorithm. An algorithm is like your model. You pass it through the model, it will now predict what's the output. Is it what? So it's just like you take employee data or customer data, and you're now predicting whether the employee is happy or not happy, whether customer is satisfied or not satisfied, isn't it? So at this point here, this is what we call our what? Dependent variable. Can you see that? So it depends on what we are trying to measure. That will call what? The independent variable, which is usually summarized as y as a function of what? X. Can you see that? Where y represents what? What does y represent? What does y represent?
The dependent variable.
A dependent variable. Yx represents what?
Independent
independent
variable.
Dependent variable. So in machine learning, this dependent variable is what they call what? Your target. Do we get that? It's called what? Your target. Why this your x is called what? It's called what? Your feature. Did you get that now? It's called what? Your feature. This is target or outcome. Okay. So this your independent is called feature. Did you guys talk anything about feature engineering, feature selection? Did you talk about feature engineering, feature selection? Did we talk about feature engineering or feature selection?
Not really. Maybe just normalization and standardization.
Okay, all right. So when you say feature engineering, right? Feature engineering, feature selection. So it just means, for example, let's say, for example, sales. You notice sales is going down. So what do you think drives? What's the driver for sales? What drives sales? What drives sales? What drives sales?
Price.
Price, right? Price, okay. Which price? You know you have different prices though. So which price? Which price?
Selling price.
Selling price. Now, do you see that in your, what do you call it now? In your sales, to get sales, do you know that your sales is made up of price and quantity? That's your sales revenue.
Yes.
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 So it's already embedded in your sales. Yes. So that's why before we build any model, we need to understand how they are measured. Do you get? How is it what measured? That's why you must be clear about it. So let's think about again what drives sales. What other factors will drive sales? What factors will drive sales?
Marketing.
Adverts.
Marketing cannot come in now. So as a function of what? Marketing. What again? Now, for example, if you say
Location.
understand how it works. So understand how it works. This your outcome variable. These are your features. From a variable, right? Remember what's the variable? What is the variable? What is the variable?
Take any data input.
Is that? A variable is what?
You can assign data to a variable.
Okay, so we are talking in terms of the basic of Python, right? Programming. Yes, that's variable. But generally, a variable is something that can take anything actually, right? It can take anything. But in that variable, we need to what? We can classify them into two. Whether it is what? Qualitative or quantitative. Is that not right? Your variable can either be quantitative or what? Qualitative. All right. Now, based on that variable, we must have a way of what? Measuring it. Is that not true? For example, if I say sales, how do you measure sales? How do you measure sales? How do you measure sales?
Quantity and price.
So now you want to measure it either in terms of volume, right? Or in terms of value. Can you see that? So if I say sales, I can talk about sales value, sales volume. That's maybe the quantity. I can talk about sales revenue in terms of the value. Can you see that? So anytime you want to measure it, you must be clear how it's going to be measured. When you want to explain it, you must be clear how it's going to be measured. Okay, so measurement is key. So it is based on that measure that you now go and generate what data. Do we see that now? So if I say sales now and we agree, okay, we want to use what? Sales revenue. What data do I need to get sales revenue now? What data do I need to get sales revenue now?
Quantity and price.
So I need to go and get data on quantity. I need to get data on quantity. I need to get data on what? Price. So when I now multiply it, it now gives me what? Sales revenue. Is that not it? Good. Now, marketing. How do you measure marketing? How do you measure marketing?
Rich.
Yeah?
Rich.
Reach. Okay. Can we be more specific when you say reach?
Or leads. Leads generated.
Lead generated. Okay. So somebody talking about reach, somebody talking about lead. Any other way to measure it? Is there another way to measure it?
Visitors to your website.
Okay, so it can be visitors to website, number of visitors on the website. Okay. Any other way?
Number of sales can also be quantity.
So number of sales. So when we say number of sales, right? Will that be captured?
Quantity code.
Will that be captured in your volume? Or is it different from?
Yes, it will. It will.
It will be captured, right? No.
Yes.
Okay, apart from marketing, what else? What other factor can drive our sales? What other factor will drive our sales?
What
Can we
about
say the
location?
quality
What
of the
about
product?
location? Can location also?
Okay. Location. So how is location going to be measured? How is location going to be measured?
Maybe the number of times you provide products to a particular location. Maybe that can determine the sales turnover. So
Okay, but how do you measure that location? And how do you measure that location? How do you measure that location? Because this is what I'm always emphasizing on. This measure is really important. Because if you are not able to measure it clearly, you cannot get the data. If you cannot get the data, you cannot run the words. Apply the machine learning algorithm. Because at the end of the day, remember, machine learning is about learning from data. Can you see that? You must learn from the data. All right. And based on that data, that is how the machine will learn the pattern. Okay, I'm seeing this word pattern, I'm seeing this word trend. So that's why your machine learning is made up of two parts. One is what? The data. The other aspect is what? The algorithm. Can you see that? But for you to get this data, you must be clear how it was measured. Have you got that now? So when we say location, so how do we measure location now? How do we measure location? How do we measure location?
By square meter.
Is that?
By square meter.
By square meter. Okay, by square meter. Now just think about it. Now let's think about your own business, right? So if you go to your customer now, or your customer, you go and supply your customer, you actually measure their square meter of their premises. Will you measure it that way?
So now be distance to the market now.
So one, it can be distance, but distance can be there. Okay, distance. Okay.
Kilometer.
Yeah. You said what?
No, I was responding to you that's by kilometer when you talk of the distance.
Yeah, distance by kilometer, okay. So the further they are, the whether more likely or less likely they are to buy from us, okay? Probably give that to hypothesis, okay? But again, other way to measure it. Now, sometimes you remember that this variable, say the variable can be quantitative or what qualitative. Is that not what we said? This distance here, is it quantitative or qualitative? The distance here, is it quantitative or qualitative?
Quantitative.
It's quantitative, is it not? Now, for
Yes.
example, I can also measure location, whether it's what, urban area, or what, rural.
Rural. Yes.
I see that. At that point, now becomes what? Qualitative, is it not? But I
Yes.
cannot use urban and rural that way. So what do? I now have to now transform it into a quantitative way. So for example, if I'm interested in urban, I will assign 1. Otherwise, 0. Can you see that? This is what they now refer to as what? A dummy variable. Did we talk about dummy variables? Dummy variable.
1 and 0.
Yes.
I think.
1 and 0. Sometimes we call this technique known as one hot encoding. However, did you talk about one hot encoding? We call it one hot encoding. Although that comes to when you are now doing transformation, but the point is that when you are measuring, it can either be quantitative or what qualitative. But always think about how do I get my data? How do I measure it? Okay, so this your marketing, this your location, is it not? These are referred to as what? Features, is it not? They are called what? Features. So what I have done here, I selected marketing, I selected location. For example, we can select, what again can we select? Maybe income level, is it not, of the customer? Income level of the customer. That's another what? Feature, is it not? So what we have done here is called feature selection. Did you hear that term, feature selection? Feature selection. So feature selection, what does it mean? Feature selection, what does it mean? Feature selection, what does it mean? What does feature selection mean?
Feature selection actually refers to when you have a set of data with several variables, you now narrow down to the particular variable you are interested in.
Yes, so those are feature selection. So what we have done here, we selected what? Marketing. We selected location. We selected income level, is it not? So those are our what? Features. What is our target variable?
Price, sales.
Sales, is it not? So it means what's our model now? Our model is what? Sales equals to what? Maybe I can have alpha 0 plus what? Alpha 1. So we are transforming from the functional model to more of a mathematical model. Can you see that?
Yeah.
Alpha 1 what? Marketing plus alpha 2 what? Location plus alpha 3 what? Income level. Can you now? This is our model. Can you see how to build the model now? This is now what? The model. And what's the objective of this model? To try and predict what? Sales. Is that clear? Is this clear?
Yes, sir.
All right. So probably let us illustrate it in Excel, because I'm sure when we start it from Excel, it will make more sense for us, because most of us are familiar with Excel. Because when we get to Python now, the same thing we are going to build, but
Get
set
that.
of variables
is
about
that what?
But I think it's better you take it online and get to do it.
Hello, what do you say?
Doctor,
Yeah?
sorry to take you back. Please, I didn't really get the explanation for feature selection.
Okay, feature selection. Okay, let me
Yes, please.
okay, sorry, let me open
Thank
the
you.
Excel and try and explain it from Excel. Because in Python, it will be looking like all of them. So let's not get us away. Let me see. Okay, good. Can we see this? Do you remember this data? Am I sharing my screen? Can you see my screen here?
Yes, sir.
Good.
You can see your screen.
Good. Now you see sales, right? For example, if I take sales advert, that means I can just take sales as a function as advert. That is one model. Sales as a function of what? Advert. That's one model. So it means if I want to write it mathematically to be what? Sales is equal to what? Maybe A plus what? B advert. Is that what it is? Or sometimes more technically, they will write it as sales is equals to what? Maybe beta 0 plus what? Beta 1, is it not? Advert. Where this A represents what? What is this A? What is this A?
Advert.
A here is what?
Constant.
A constant intercept. Do you remember the line of your equation of a line?
Yes.
I is equals to what?
A plus B.
A plus B X. Do you remember this expression?
Yeah.
What is A here? A is what?
Intercept.
Intercept. Can you see that A is what? Intercept. And what is B?
Slope.
B is what? The slope.
Slope.
And that B slope represents what? Change. Can you see that? So if this changes, by how much will Y change? Can you see that? So it's looking at what change. That is how we are using to predict. So if this change, if advert changes, by how much will sales change? Can you see that? Have you gotten that? So
Yes.
if I want to add another variable again, so let's say now B2. B2 what? Volume, is it not? Can you see that? So if these are the two variables we have selected, this is now called what? Feature selection. Exactly. It's called what? Feature selection. So it is based on the variables I have selected for my model. So that's what they call feature selection. Are we okay with this now? Are we okay with this?
Yes.
Good. Now, if you look at this model, so let's say, for example, you believe that there's a new way you can even generate a new variable. Let's assume that the measure you have thought about is advert divided by volume, right? Advert to maybe you have a new way of measuring certain things. So you now decide to do equals to advert divided by what? Volume, is it not? You now have a new variable, isn't it? Or you decide to say advert square. That's your variable. So equals to what? Advert raised to power 2. Can you see that? Do you see that from the existing variable, we have generated new variable? Can you see from existing variables, we have generated 2 new variables? Do we see that?
Yes, sir.
Doctor, please, can you do that again, please? I didn't
No,
quite get that.
this one doesn't make sense. I'm just trying to explain the concept.
Okay.
I'm just trying to explain the concept, right? I'm trying to explain the concept. That from existing variables that you have, you can generate new variables. For example, advert, we do advert square. Or there's a measure we talked about that is advert divided by volume to measure certain metrics. Okay, so in this we have generated 2 new variables. Is that right? We have generated
Yes.
2 new variables. So this is referred to as what? It's called what? Feature engineering. It's called what? Feature what?
Feature engineering.
You know, engineers like to produce. So now they have designed and now produce new variables. So they are called feature engineering. I hope this is clear.
Yes, sir.
Is this clear? Is this clear?
Yes, sir.
All right. So what are we trying to do? We are trying to explain what are the factors that drive sales. Is it not? And we believe it's advert and volume that drive sales. Okay? Advert and volume that drive sales. If that is your belief, then the question, what question will follow it? What question should follow that? If you say it's advert and volume that drive sales, what's the question that will follow it?
To what degree?
What degree? And before you ask what degree now, you have identified the variable. What's the next question you ask? You have identified the variables. Now, what's the next question you ask?
Is it a positive or negative relationship?
Before you get to that stage, now that's another level. What's the next question you ask? You say, oh, advert and volume drive sales. What's the next question? What is the next question that should follow it?
Cost of advert.
Yes, the next question should follow it is what? How is it going to be measured? Do you see that? How is it going to be what? Measured. So if you say advert, how are you measuring adverts? How are you measuring volume? Do you see that? Once you have measured how you are measuring advert and it makes sense, because there are 2 things we need to understand. One is that it must be what? Explainable, must be logical. And that is why you see, when you are doing your regression, right? Regression. I don't want to look for trouble here, but start part is that because we need to just explain a bit of the theory for you, right? We need to explain a bit of the theory for you. You see, before this algorithm makes sense, there are certain assumptions. Okay? One of the assumptions is that the model must be correctly specified. It must be what? Correctly what? Specified. Now, if you look at the situation, for example, when you are running a, because normal example I usually give in class, if you are running 2 variables, right? Let's say 2 variables. Let me see. Okay, let's say we have these 2 variables, right? Let's say this is price of chicken, and this is price of toothbrush. Is it not? So this is price of chicken and price of toothbrush. What is the relationship? What do you think is the relationship between price of chicken and price of toothbrush? What do you think is the relationship? What is the relationship between price of chicken and price of toothbrush? Is there any relationship?
Is it safe to say there's no relationship?
Huh? You said what?
Sorry, you said
I
price
said,
of
is it safe to say that there's no relationship between the two of them?
It's very safe to say that, man. Very safe to say. Is there any actual practical or logical relationship between both of them?
No.
Is there anything that relates price of chicken and price of toothbrush?
No.
Economy.
No, is it not? But do you believe that if you collect data and run it and go and check run correlation, right? You check the correlation of this variable, So this variable, I'll run the correlation of this variable, comma, and of this variable. Can you see that? What does it tell us? What does it tell us?
Strong positive.
There's a strong positive word correlation. But in reality, is there any correlation?
No.
No.
No, is it not? So this is what they refer to as what? A spurious, they call it what? Spurious correlation. You know what something spurious means? Nonsense. Makes no sense. You know, makes no sense.
Yeah.
But you see, statistically it's giving us results, but practically it's not explainable. It's not explainable. I see that. So when you are thinking, you need to clearly define your variables. That yes, it is advert that drives sales. That is why correlation is not the same thing as causation. Can I see that? Correlation does not imply causation. Okay. So we must define it. What is causing what? So at this point, we are saying it's advert that is causing what? Sales to change. Can you see that? So we are clearly defined. That was the first one that was your model must be correctly specified. Okay? So when you are picking those your features, ask yourself, does it have any practical relationship, interpretation? So you don't gonna have situation like this. Is that clear? So when you are trying to find out what factors explain, what are the determinants of this? You are looking at what's driving it. What are the drivers? So based on your experience, based on your observation in the industry, right? You can now come up with this word variables. So based on these variables you have come up with, you need to be clear how they are what measured. Then after you are clear with how they are measured, what's the next question that will come up? 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 Yes? What's the next question that will come up? Once we are clear with how it's measured, what's the next question that will come up now?
We get the data.
Where will I get the data from? It's not where is the word data. So sometimes we already assume because we are seeing data that's how it works. That one need to be clear on how the flow works. Most times we just see the data and we start running it, but you need to understand how it works. So it starts from the problem, you know, the problem. So that's why most times you have what a problem statement. Based on that problem statement, you now raise the questions. You know, from those questions, you now identify the variable. From the variables, you now think about how they are what measured. From their measurement, you now ask yourself, how do I get what the data? Now I have gotten the data. What's now the next step? Now I have gotten the data. What's now the next step? Now I've gotten the data. What's the next step? Now we have got data. What's the next step?
We analyze the data.
When you say analyze data, what do you mean by analyze data? At this stage, you see what we did here? We now built a model. Can you see that? We now built the model. Can you see that? That was where we now said, okay, now we have this data. Y is a function of X. We now build that model. Based on this model, now what do we do next? We are going to apply what? The algorithm. You see that? Now apply what? The algorithm. When you hear algorithm, what does an algorithm? What does it mean? Algorithm, what does it mean? When you hear algorithm, what does it mean? What do you mean by algorithm?
Algorithm.
What is an algorithm? What does an algorithm mean?
You said it's about pattern recognition.
The algorithm, right? So algorithm itself there, yes, the pattern is, you can say pattern recognition, right? You can say pattern recognition. But again, beyond that one, let's say from an English point, let's try from an English point. Algorithm, what does it mean? Algorithm.
It's a sequence of instructions.
Sequence of what? Instruction. Is it not? So for example, you want to make tea. How do you make tea? How do you make tea? You want to make tea. How do you make tea? How do you make tea?
Boil water.
You boil water.
Boil water.
Boil water.
Add.
What do you do next?
Add whichever tea.
What kind of tea?
What kind of tea? Correct.
Good. So first of all, the first step is that you boil the water. You know, you pour the water into the cup, right? Or depends on the method you like. It's not. Some people rather put the tea inside while it's boiling. Some will decide, okay, let me put it inside the cup, then put my tea inside. It's not. So now the question is, what type of tea? Is it green tea? Is it which other type of tea do you have? What other type of tea do you have? Yes, green tea. Which other type of tea do you have?
There's black. Yeah.
Black tea, right? So you have different, so you can green tea, black tea, you now choose whatever tea you want, you know. Once you have now poured it inside the cup, now what do you now do? You now what? Stir. So some people would like to add milk. Some people would like to add sugar, is it not? Then they will now stir it. Can you see that? But do you see that there was a step? We boil the water, we pour it in the cup. From the cup, we add maybe sugar or add the tea on it with sugar and milk. Then we now what? Stir. You see about 4 steps there, is it not? That's an algorithm. Do we see that? That is what an algorithm. Okay. But algorithm in regression also means there are steps to it. You see this regression that we are doing. You see this regression that we are doing. Can I rub up this nonsense I'm writing here?
Yes, sir.
Yes.
So we agree it's nonsense.
Not really.
I hope you are taking note of it, right? The steps. From the problem to the question. From the question, we analyze, identify the variables. From the variable, we measure. From the measurement, we get the data. From the data, we build the model. From the model, we select the algorithm. Can you see that now? Good. So now I can rub it off. Now I can rub it off. Now you see, that's your Y. as a function of, let's say, a plus bx. A plus bx. Right? I'm sure this one, does it make sense to us now? Does this make sense to us? So
Yes,
maybe
sir.
beta 0 now.
Yes.
Beta 0 and beta 1. You see the same thing. Is that okay? Now, you know, this is what they refer to as a simple regression model. A simple regression model. So, for example, here we had what? Was it adverts and was it adverts and sales? Or sales and adverts? Okay, here was sales and adverts. Let's assume sales and adverts. So in this case, you see, which is the dependent variable here? Which is our y? What is our y here?
Sales.
Our y
Sales.
is sales. What is our b1? Our x. Our x is what?
Advert.
Our x is what? Advert, which means sales is equals to what? Beta 0 plus what? Beta 1 what? Advert. Can you see that? Now, is it only advert that drives sales? Is it only advert that drives sales?
No.
Is it only advert that drives sales?
No.
So you are seeing that there are so many other factors. So we now use what they call error term. Can you see the error term? That's what they call the error term. So error term, what does error term represent? This error term, what does it represent?
Unexplained variables.
The other what? Factors.
Other factors.
The other factors. So what's our objective? Our objective is to determine this value of what? Our intercept. This value of our what? No, coefficient is not. And it is based on that, we can now what? Explain the relationship between advert and sales. We get that now?
Yeah.
Now, since I have got that, I will now apply an algorithm. So remember, machine learning is about what? Machine learning is about what? Yes, machine learning is about what?
It's about learning data.
Learning from the data, is not looking at the pattern from the data, right? Looking at the pattern from the data. And based on that pattern, what does it do for you? Based on that pattern, what does it do for you?
It predicts.
You now use that to what? Predict. Can you see that? You now use what? Predict. So let's see how it works now. In regression now, so let's do that. Remember, the model must first of all correctly specified. Now, the next question is, how do I know the algorithm I'm going to choose? You see that? Because there are so many algorithms. There are so many what? Algorithms. Okay? There are so many what? Algorithms. So many. There's something they call no free lunch theorem. Have you heard of that?
No.
No free lunch theorem. What does it say? No free lunch theory. What does it say? No free lunch theory. What does it say?
No free lunch theory. It means that nothing is free, even in free time.
Even in free time. All right. So no free lunch theory. What does it say, right? It simply says that yes, we have so many theorems, theorems, different algorithms, but there's no one best algorithm. Do you get that? No one best. So that is why you don't just choose one, you choose what? Several what? Algorithms. Can you see that? You choose different what? Algorithms. And what do you say an algorithm is? What do you say an algorithm is?
Sequence of instructions.
Sequence of instruction, is it not? sequence of instruction. Only I don't go to mathematical because all this one there is a mathematical derivation for it. Because our objective is to minimize this error. You know, we want to minimize this error. Okay? And to minimize that error, you now make it subject of formula. Then there's a derivation for it. Do you want us to go into that?
Oh,
Okay, so let's do this. So now, based on the algorithm, so based on the machine learning, we can classify all those algorithms basically into two. However, some will argue into three. Some may argue into four. I don't know. So it all depends on your own school of thought. Okay? But let's make life easy for us. So let's start with the easy one first. So you can choose which one, whichever one you want. We can choose based on what they call supervised machine learning and what? Unsupervised machine learning. I'm sure you guys discussed this. Right? That machine learning can be divided into two. What are they? Supervised machine learning
and unsupervised
and what?
machine learning.
Unsupervised
Supervised.
machine learning. I would say under supervised, what does it mean to be supervised? Right? What does it mean to be supervised? Now you see, in supervision means first of all, we must have a clear label. There's a label. I will explain what label means. In unsupervised means what? There's no what label. No what label. All right. You know the normal example I usually give in class for this, our Nigerian police. Is it not? Our Nigerian police. Now, if they see a young man driving Benz, is it not? He's driving Benz. He's having dreads, with earring, with tattoo. What do they do?
Yeah, we are with the
They'll
target.
stop him.
They will what? Flag it down, you know, because why?
Yes.
They are able to what? Classify him, is it not?
Yeah.
They are able to what? Classify him. So that's what they call classification. So either it's Yahoo or what? Not Yahoo. Can you see that? That's classification. You are predicting, is this fraud or not fraud? For bank loan, this customer comes in, is he going to default or not default? Can you see that? That is called classification. Do we get that now? Is that
Yes. Yes.
now, but where the variable, so you see by default, so let me explain this now. You see, here we have y is equals to what? A plus bx. Right? This is what they call a simple regression model. Simple. Why is it simple? Why do you say simple?
Because it has only two variables.
Only two variables, one dependent, one independent. Our dependent variable is called what?
Why?
Yes, but what is it called? What's another name for this
Sales.
variable?
Um,
Another name for this variable is
Another
called
Target.
target. You know, this is your target. You know,
or outcome.
or
Okay.
outcome. Exactly. Target or what? Outcome. Why is
Outcome.
our x is called what?
Feature.
Features.
Our feature. Is it not our feature? Okay. Good. So in this regression, linear regression. So one of them is that we are seeing there's a linear relationship. You know, first of all, the model is correctly specified. And that one is that there's what? A linear relationship. You know when you say something is linear, an increase in one will lead to one unit increase. So non-linear means one input may lead to 5 output. 2 input may lead to 12. You know, it's not the same pattern it's following. So we are assuming what? Linear relationship. Now, another relationship is that this is our value of y. Can you see this is our value of y? The value is what? Random. Can you see that? When you say something is random, what does it mean? When you say the variable is random, when you say the variable is random, what does it mean? When you say the variable is random, what does it mean? The random variable, what does that mean? Yes? When it is random variable, what does it mean? When it is a random variable, what does random variable mean? Something random. What does that mean? Random.
Does that mean that you can pick any number?
It
It
can
can be
take
any.
any value. Can you see that? It can take
Yeah.
any value. So it means, first of all, this variable must be what? Quantitative. Do we get that? This variable must be what? Quantitative, and it must take what? Any random word value. It can be 1, it can be 10, it can be 12, it can be 13, it can be 100, it can be 1,000. It can take any word value. Do we see that? So the moment our variable, this target variable is quantitative, and our objective is to predict this quantitative value, then we use what they call the linear regression model. We use what they call what? Linear regression. So that they say it's a regression problem. This is the foundation of everything we are working with. Okay? We are using what? Regression. So that's what they call regression. So an example of a specific supervised machine learning model is your what? Regression model. It's your regression. But now, where is your dependent variable? Let me clean this nonsense again. I hope you understand the first one. We understand it?
Yes.
Of regression, right? That first of all, it must be a quantitative variable, isn't it? And secondly, it must be random, is it not? It can take any value. But where now, this one, for example, fraud or not fraud. Can you see that? Not fraud. Yahoo or not Yahoo. Can you see that? Which other one again? Which other one can we have like this?
Tech boy.
Huh?
Tech something. Tech guy.
Which one?
There's one word. There's one thing they used to define it. So it's.
Or let's say in investment, you invest. You know, either it's going to be what? Profits or loss. So profit or loss means not profit. Is it not? Let's say, for example, your customer, right, will be loyal or churn or not loyal. Is it not? HR, for HR, what example can we give for HR? For HR. What example can we give for HR? Where employees live or they stay. What do we call that? Anybody HR here? So think about your own industry. So where you have just two possible outcomes. Two possible outcomes. Investment, profit, or loss. Fraud, not fraud. Okay. Customer. Either the customer is loyal or the customer will churn. Not loyal. Same to employee. Whether the employee is loyal or he will what? Leave. Is it not? Attrition, employee turnover, what they call attrition. Now, can you see that now, this our Y takes only two possible values. Can you see that? Remember, the first assumption is that what? What's the assumption here? What's our assumption here? What's our assumption at this point?
That it must be quantitative.
It must be quantitative. What is, by the way, what is quantitative? Our Y, not our target.
Yeah.
Quantitative and what is random.
It can take on any random value.
In that case, which algorithm is most appropriate for that? Which algorithm is most appropriate? Which algorithm is most appropriate in this case? Which algorithm is most appropriate? Which algorithm is most appropriate in this case? It's not here. You cannot see it here.
No.
You cannot see it. I have been feeding you the answer, feeding the answer, feeding the answer. I say it out. What is called overfitting. It's called overfitting.
Ah, okay.
This is an example of overfitting. I'll give you the answer, I'll give you the answer, I'll give you the answer. And I say, I test this one now. I see that. This is now overfitting. Alright. Okay, I look at it here now. The most appropriate is what? Your linear regression.
Oh.
Now, where this Y takes only two possible outcomes. Can you see that, for example, fraud, not fraud, Yahoo, not Yahoo, profit, not or loss, lawyer, not lawyer, or churn? Is it not? Only two possible outcomes. In that case, you can no longer use what? A linear regression. So rather, what do you now use? You now use what they call binary logistic. It's called what? When you say binary, what does binary mean? What is binary?
By two.
Two. It has only two possible outcomes. Yeah. So the algorithm we use is called binary logistic regression. Can we see that? Binary logistic what? Regression. So this falls under what we call classification.
Under what? Say that again.
Classification.
Classification, okay.
Because when police see you, you see that Yahoo, not Yahoo. So as a woman, when they see you, how would they classify you? Yahoo or not Yahoo?
Not Yahoo.
You allow you to. You allow you to. And that young man comes again. Ayobami with us, with a Benz, with cap to the back. Is it not? How would they classify Ayobami?
Yahoo.
Yahoo, so you flag him down. Is it not? So only two possible outcomes. Can you see that? That's what we refer to as what? A classification problem. Do you understand that now?
Yeah.
So for classification problem, what algorithm do we use? What algorithm do we use? For a classification problem, what algorithm can we use? For a classification problem, what algorithm can we use?
Okay. Supervise.
Yes, we supervise.
Binary logistic regression.
You can use what? Binary logistic, or what is just called logistics. Can we see that? So that is what supervise, because here there's a label. It's fraud, not fraud. Yahoo, not Yahoo. You already labeled. The same thing with a child, right? You can tell a child, this is good, this is bad. This is good, this is bad. You know, you have already labeled and told him that's supervised. You are supervising him. But you know, the same child can still learn on his own. He can still learn something on his own. Do you know that?
Yes.
He also can learn something on his own. You tell the child, this is good, this is bad. You know that sometimes that one that you say that is bad, that's the one you want to try. Is it not? That's the one you want to try.
Yes.
Then when they now try and now experience that it's bad, okay, now I understand what my mother has been telling me. Can you see that? But sometimes you may not be there to tell them. They're on their own. They are learning on their own. So nobody is there to tell them what is good and bad. At this point now, there's no label. Can you see that? There's no label. Nobody to tell them what is good, what is bad. They are now learning on their own. Oh, based on these characteristics, I can now see, okay, this one can be good, this one can be bad. Now they classify it on their own, with nobody telling them what is good and what is bad. So that is what they call unsupervised machine learning. Okay? Same way with the police, the way they will now tell you Yahoo, not Yahoo, that's a supervised. But the one they go to maybe, on Fridays now, or on Friday where guys are drinking, they will come and arrest everybody, carry everybody to the station. Is it not? They will now start sorting you out. They don't know who is Yahoo, who is not Yahoo, is it not? But based on certain characteristics, women stay one side. Guys with dreads, tattoo, stay one side. People that look like a pastor, look responsible with suits, or stay one side. What are they doing? They are what? Clustering them. They are what? Grouping them. Same thing with your customers. You can also what? Segment your customers based on certain what? Characteristics, based on their income level, based on their level of education, based on their age. You are clustering them. You are putting them into groups. So that's what they call clustering. So the algorithm is called what? Clustering. It's called clustering. I hope this is clear.
Yes.
Are we clear with this now? Does it make sense when to now choose the particular algorithm we use? When we get to application, I will explain other algorithms, but this is just a foundation for you to understand how it works. I hope we are clear up to this point.
Yeah.
However, is there anything you want to add to this?
It's something like, last time when we were looking at it, because when they classify this machine learning, there's also another one, they say reinforcement learning. There's another.
That's why, so that I said it depends on the school of thought. That reinforcement learning actually is still part of your what? Unsupervised. But however, they can now separate it and now tell you that this is a bit much more advanced. They now call it reinforcement learning, or what they will call deep learning.
Deep learning, exactly.
And
an offshoot of it is also generative AI.
Aha, hey, he's a real consultant now. Large language models, generative AI. Okay. Because we are just introducing, that why I don't want to really go into all this one at this level. Probably that's why I don't want to go at this level now. So now I'm just laying the foundation. But once they start breaking it, once they get into this now, okay, they can now understand, okay, there's also this aspect, there's also this aspect. Now, this is the current stage we are in now. This generative AI. Large language models. Large language models. So the only difference here is that the way we have been doing input and output, you see we are using numbers. Now it has gotten to the stage where it's now using what they call natural language processing. The way you talk as a human being, is it not? As you are talking, as you are typing as a human being. So when you type as a human being and then say, what is the feature of a good business? What is the feature of a good business? Is it not? That's a text you have mentioned. That's an input. It will now go into the internet. That's internet now represents what? What does internet represent? What does internet now represent?
Your population.
Your data.
Where it gets the
So that's your
data
data, is it not? It will now go into that data. Look for the patterns. Bring it out. What people have said in the past, and now give you the output. So that's now using what text language. So this is where we are currently. This is where you now have your ChatGPT. So they have developed from this level to this point now. You get that now?
Yeah.
So that's what they call deep learning. deep learning. Your Tesla cars, right? They use what? Deep learning. But in this case, they don't use text. What do they use? Tesla, now what does it use? Tesla, what does Tesla use? ChatGPT use natural language processing. What does Tesla, what do you think it uses? So as the car is moving, so how does it see what it's doing?
Video.
It uses what? It uses what?
Video.
Video, right? Video. And that's what they refer to as what? Computer vision. It's called what? Computer what? Vision. Do you know even picture? Do you know a picture? Do you know a picture is data? You know picture is data. You know picture is data. Because everybody's picture, do you know that if they break it down into those pixels, you know there's data for everybody on your face. So that is how they do what they call facial recognition. That's how the system can recognize who is who. Like on Facebook, have you ever noticed that on Facebook, by the time you put you and your friend, you know you can tag your friends based on the person's picture. Have you observed that? They can tag the person's picture, the person's face. Especially if you have done that in the past. The moment you just see the person, okay, I've seen this person's face, I know who this person is. It's called facial recognition. Okay. Even your Google Map. Google Map, what does it use? Google Map, what does it use? What does Google Map use? What does Google Map, what does it use? Your Google Map, what does it use?
Use geographical data.
It use what?
Geographical data.
Geographical data. What they call geospatial.
Special.
Geospatial data. And also even that noise, even like your Siri. Siri uses what? Audio, is it not?
Yeah, voice.
Voice, you know, so that's voice recognition, facial recognition. So this is now where we're now talking about the applications of this machine learning to what? The computer, which we now call what? The AI. So you see, machine learning is an aspect of what? AI. It's just an application of what? Your AI, right? Or the AI is the application of your machine learning. So it's all about what? Pattern recognition. And it all starts from what? Regression. This is the foundation of it. Regression. So I think we have explained most of this one. So let's try and do a little bit demonstration. Or general concept confusing us. In fact, we have not even got to what will confuse us with confusion matrix. However, did you talk about confusion matrix? Did you talk about confusion matrix?
I just mentioned this when we are doing a test run.
Okay, confusion matrix. That one will still confuse us to we have not gotten there yet, but that's fine. So what we have seen so far, that machine learning involves what? Using the machine, the computer, you know, to recognize pattern based on what? The data. By applying what? Certain what? Steps, you know, rules, algorithms. So it is based on that, it will now help you to do what? Your prediction. It is based on that, it will help you do what? Prediction. But now, there's another concept again we need to understand. Is there a difference between forecasting and prediction? Is there a difference between forecasting and prediction? Is there a difference, or are they the same thing? And forecasting and predicting, are they the same thing? Are they the same thing? Forecasting and prediction, are they the same thing? Yes, are they the same thing? Forecasting and prediction, I think the same thing.
Forecasting is based on data. Prediction is can use other methods for evaluating what you want.
Yeah, but you know, since we have been talking about prediction, this is not all data we have been using.
Based on the model. Forecasting is probably based on the model.
Prediction is based on what?
Other empirical factors.
But what we explained, John, what we have been explaining is what we're not talking about predictions. It's still based on the model.
I think forecasting is a sub of prediction.
Now, most times we use them interchangeably, right? We use them interchangeably. But technically, right? Technically, see what happens. If you remember your data, remember how we start with data. How we collect our data. We're talking about the source of data. We talk about what? The nature of data. And we talk about what? The timing of the data, is it not? I'll say under timing of data, what do we talk about? Under timing of data. Under timing of data, what are we talking about? Hello. Under timing of data, what are we talking about?
Past of historical or future. Historical, present or future.
Timing of data, what are we talking about under timing of data?
So is this about over a period of time, like years, months, days, and all that?
Yes, what
okay, static or
either the data is at a point in time or the data is over time. So data at a point in time, what do we call it? Data at a point in time, what do we call it? Data at a point in time, what do we call it? Data analyst.
Cross-sectional.
Cross-sectional and time series.
Cross-sectional data. Why data by a period of time is called what?
Time series.
Time series data. So whenever we are trying to estimate the future, so one thing they have in common that they want estimate the future, or it's about estimation. When we are estimating within the time frame, right? Which is like cross-sectional data, then we talk about what? Prediction. But when we talk about time series data, estimating over a period, going beyond the time frame, it is called what? Forecasting. Do we see how they apply? So whenever you are talking about a time series data, what we apply is called what? Forecasting. For cross-sectional data, we call it what? Prediction. Do we see that now? But another thing again, we need to know that sometimes, especially for time series data, we need to do what? Prediction before what? Forecasting. So let me quickly illustrate that how it works. So if you look at this, right, we have the data like this, right? What's our model in this case? What's our model here? What's our model? What's our model? What is our model? What is our model? What's our model here? Oh. Yes, what's our model? It is our data.
It's a
What is our model?
It's better over a period of time, isn't it?
Yeah,
I'm
but
serious.
I'm talking about the model.
A linear model?
Okay, it's a linear model, okay? Let's say the linear. But if I say ask you to specify the model now, specify the model. How do you specify the model?
Sales is equals to intercept
Y,
plus
What's our y now? What's our y in this case?
Y, sales
sales
As a function of what? As a function of what?
as a function of adverts.
As a function of what? Adverts.
Advert.
Which we now write mathematically as sales equals what? Either
Equals to A plus
intercept, yeah.
beta what? One what?
beta 1
Math plus
advert
what?
plus ET.
Error 10, is it not?
Yes.
Now we have measured it, we have got sales, we have got this. So now our objective is to determine what? Our intercepts. And to determine what? Our slope.
Slope.
Can you see that? And there's a function in Excel equals to what? Intercept.
Intercept.
And what's our known y's?
Sales.
Sales. What's our known x?
Advert.
Advert. Can you see that? Known y, known x. What is our slope? So there's a function called slope. What's our known y's?
Sales.
Sales. What's our known x?
Advert.
Good. Can you see that? Based on this, we now know our model as what? Sales is equal to what? B0.
To intercept.
We know B0 now.
Yes, intercept. 20
let's say 28.65 plus what?
plus slope 13. What is that?
Point less than 9 what?
13.90.
9 adverts, you know?
Yes.
So what have we done? Based on this data we have seen in the past, this is the pattern. This is what they call trend. It's called what? Trend line. It's the trend. Or it is the pattern that it has discovered. This is the pattern it has summarized. So that pattern has been summarized using this word equation. But before we can use to do a prediction, forecast, because it is a time series data or a cross-sectional data.
Time series.
It's a time series data. So because it's a time series data, we are trying to estimate beyond the period. You know, we already got up to December. We want to what? Estimate for the next period. You know, so since we are going beyond the time frame, what is this called? What's it called? So we're estimating beyond the time frame. It's called what?
Prediction.
No, sir. Prediction. We're estimating beyond the time frame. What's that called?
Forecasting.
Forecasting. So time series is usually associated with what? Forecasting. We see that. Why your cross-sectional data usually deals with what? Prediction. So which means, for example, look at this. For this particular month, this month alone, I want to explain what has happened. So this month alone, what I'm doing at this point is called prediction, because within the time frame, within that particular point. So how do I estimate? Equal to what? What's my model? Intercepts plus what? But this is my intercept. I will log my intercept, right? Intercept, because I apply to everybody, I will log it. Plus what? Slope, I will log that slope times what?
Advert.
Can I have this? Can you see that? This was the actual, this was the model predicted for us. Can you see that? That is called predicted sales. Predicted sales. Can you see that? So based on the pattern it has seen, it was now captured using what? This word model. We now go back to now check what it has been. You know, just to see whether this model, how accurate it was. So the actual was 100, predicted 105. Actual was 110, the predicted 109. 112, 112, 115. So you see that it's never 100% accurate. So let us now check the pattern. Can you see that? Let's now check the pattern. So I'll now highlight it. So just to draw a chart to see whether they follow the same pattern or not. Okay. So I'll hold my control button down and select that. So I'll come here, use my line charts. Can we see that? Now, the predicted and actual. Can we rely on this pattern? Can we rely on this?
Yes.
Can we rely on this? Can we rely on this pattern going forward?
Yes.
So therefore, we can now use that and now go and do what? Our forecast.
Forecast.
Can you see that? So how do we do our forecast? The same way, equals to what? My intercept plus what? My slope times, maybe this is the budget for advert for next year, is it not? Plus this. So which will now give us what? 1, 6. Can you see that now? So now the model is that if we now decide to reduce it to 8 million, what will it be? If I increase it to 12 million, what is it going to be? Can you see that? Now we are now what? Doing what? Forecast. But if it was a cross-sectional data, what we have been doing at this point was what? Prediction. So if I now come here and I reduce this one to about, remember, all this is the outcome. This is the picture. So this one we are changing. So if this one I change to 7, you see it's now predicted and that's it. If you now change it to what? 8. Can you see that? If you change it to 4, okay? If you change it to whatever. So as they are changing, you notice that the values will keep what? Changing. All right. So it's based on that. You now start to see, you now be creating a new what algorithm for you. You now be creating what a new algorithm for you. But remember, because it's already passed, so it's already happened already, so you can't go and change this one. But going forward, as it's changing, the algorithm also will be changing and also be learning on its own based on the new data it's seeing. So just imagine you are feeding it new data. Based on the new data, it automatically run through the regression again, come up with this new equation, and then start using to what we predicting. So that's what we talk about what the deployment, and now deploying it live. So that's how all those your Netflix, your Jumia, Amazon, that's how they work. They work with the live model. They are doing what? Prediction. But in case of numbers now, they are not predicting using what? Text. They are not predicting using pictures. That's the only difference, but this is the same thing they are doing. So if we want to use it another method, we can now use what they call, let me clear this. So we can now use what? The menu, right? So if I come here to my data analysis toolbar, so if I come here, data analysis, I'll now come here to what? Regression. Can you see that? What is my Y? What is my Y?
Yeah, still a bit.
Sales.
Sales. My Y is sales. So I'll select from sales up to December, January to December. Because there's header, I'll check Lagos. Then I'll choose again my advert from here to what? This, isn't it? And label. So I want the result to be here. I want this result to be here. So I'll change it to output. So let me put the result somewhere here so that we can see the result. So let me say residual. Let's show me my residuals. Do I have any data there? Let me put it somewhere here. They have double of 6. Output reference. All this thing. Okay. Let me choose the advert up to this point. All right, that's fine. Okay, good. So is it the same result we had? Is it the same result? Is it the same result we had here?
Yes.
And remember that this based on this model, we now need predicted sales. Can I see the predicted sales that we need? Can I see our predicted sales? Do you remember this predicted sales that we need here? Do we see how we arrive at this predicted sales? That's exactly what we're having here. Can you see it here? Predicted sales. Can you see the predicted sales here? So this residual means the actual minus predicted. So it has already done that prediction for you. So you see how Excel can also be used to do prediction. So it's based on this prediction that we now use what to estimate going forward in time. That's what they call forecasting. It's called what? Forecasting. So how do we build this now in Python? I hope you understand this now. I hope you understand this.
Yeah.
So let's try and quickly build it in Python. So how do we do this in Python? So maybe we can use the larger data sets. Let me see data set from aha, okay, look at this one. Let me show okay, good. Okay, good. I've shared one data set just. So let's try and see if we can view this. Are we able to see the are we able to see it now? All right. Am I sharing my screen?
Yeah.
Yes, sir.
Let me copy this. Let me copy the part out. So the first thing we need to do is what? What do we need to do first? What do we need to do?
Import libraries.
Import what libraries? So what libraries are we bringing in? So we'll just bring in our normal import what numpy as empty, import pandas as PD. Probably you want to visualize it, so we use our math import what matplot lib.py plot as what PLT. Then you know because I use matplot, so I can use matplot lib inline. Right, then I can also bring in C1 import C1 as SM. This is what we normally use it. Hope I not miss anything there. So here we want to bring in our library, our data, so we got PD retrieve what CSV. So read that. Let me run that. So ZF. So that's the data, isn't it? Good. So if you look at this data now, can you tell me what's our objective here? What's our objective? What's our problem statement? What's our objective here? Yes, what's our objective here? What's our objective here? What's our objective here? Yes, what's our objective here?
I think it's similar to the sales that we did. So I
Yeah.
think that this shows like the average income per location or address, like this was like a hotel or something.
So what algorithm would we most likely apply to this case now? What algorithm would we apply to this? What algorithm would we apply to this? Yes? What algorithm do we apply to this? So at this point, we should be able to identify first of all what's my objective, right? What's the problem statement? What's the objective of my analysis? Based on that, I will identify the variables that I need, isn't it? I know how they are measured. I have the data. Based on the data, I will now build the model. How will we build the model in this case? What's our model here? We need to know what's our Y and what's our features. No, what's our target and what's our features. So what's our target in this case? What's our target in this case? What's our target here? Is the price. No, we are trying to estimate what the price of the property based on these features. The average income, house age, can you see that? Based on that. Now, this address, for example, most times when you are working with it, when you are trying to do everything must be quantitative. Like, for example, this address now, I cannot do anything with it unless there's something I want to extract from it. If I cannot use it, then I'll just drop it. Okay? So how do we drop it now? So either I just select, maybe for example, I just select the columns. So I just know, okay, I will need maybe from average up to price. And I'm okay with that. So this I'll say DF is equal to what? DF, then I have that. So when I run DF now, can you see that? When I run my DF, I now have this slot. So what's my dependent variable here? What's my target variable here? What's my target variable here?
Price.
Target variable here. What's my target variable here?
Price.
Price. You know, my target variable here is what? Price. And price represents what? My Y. You know, that's my Y. You know? So
Yeah.
Y is equal to what? DF price. Can you see that I've separated that this is my what? Price. Because that's my what? Target variable. So when I say Y, Y represents what? All my prices. Can you see that? Then my X represents what? What's my X? My X represents what? All these up to this point. You know, those are my what? My X represents what? X represents what? X represents what? What does X represent?
Features.
Not features. They represent your what? Features, your independent what variable. Okay. So the next thing we do normally is to now break this data into two parts. We'll break it into two parts. Now take note. Whatever you do to X, you must do to Y. Whatever you do to Y, you must do to X, but they must be on the same base. So if I remove a variable here, I must remove a variable here. If I reduce data here, I must reduce data here. So whatever I do to one, I must do to the other one. Do we get that? So what we are going to do here, we are going to break it into two, into what they call the train data and test data. Okay, we'll break it into two, train data and test data. Is that clear? So how do we do that? We now have what? So there's now a library what you call your sklearn. I don't know if you talked about sklearn. So for example, I can say from sklearn dot model selection, right? Import what? Train, test, split. Or you have just got to import it once and just say import sklearn and now import train, test, split. So to do that, we want to break it into 4 parts. For Y train, Y test, X train, and what? X test. I hope you understand it that way. So we have what? For example, X what train, comma, X what test. We have Y train, comma, we have what? Y test. Do we get that now? So it simply means break it into these 4 variables. X train, X test, Y train, Y test. Then we now have to use the this function now. Train, test, split. Train, test, split. We are breaking it into 2 units of X and Y. Right? Now, what's our test size? What test size are we using? Test size means how are you breaking it? I want to break my train, so sometimes you can use 80% to train data, while 20% to test. Some will use 75% to train, 25% to test. Some will use 90% to train, 10% to test. But best practice, this is what most people use. Okay, 80-20 just to what test. Because the higher your train, the more likely to be what over test. Okay. So here we say test size will be what? 0.2. Does that make sense now? 0.2, does it make sense now? Why is it 0.2?
20%.
It means 20% to test. Is it not? Then you now have what they call random now you know in Excel, you know random when you use random data. Random, right? Random. Okay. So when you're using random, this is going to generate random data for you, not? But now we want to say, okay, even when you are generating the random data for me, make sure that we have the same. So even if you are using the same random data, we'll pick exactly the same random distance. So it's called random states. So if I say random state 100, we will get exactly the same random data. But if I just say random, if I don't pick the random data, you just pick whatever data that I want. Okay? So that's why we normally use just pick any random data, take 80%, any random 80% of the data set. Okay, so let's run that. Oh, edits are from invalid syntax. So where are these? Edits are from. So where is it now? Okay. Test size 20%. Okay, test size 20%. It's just one command and cause problem for me. So now remember I've broken it into how many now? X train. So look at it, X train. This is my data. Can I see that? Y train. This is my data. So I'm working X train, Y train. So when I want to do test, it will now be what? X test, Y test. Do we see it now? So have you got to this? Do you understand up to this point? We have now split the data into 2 parts, the train side and the test side. Is that clear? So now we are going to build the model now, right? So what model are we going to use? Which algorithm are we going to apply? Which algorithm are we going to apply?
Line equation.
Yeah? Which one?
The line equation.
Mention the specific
Y
one.
is equal to A plus.
So that's linear regression. It's not. We're applying linear what? Regression, isn't it? So we now apply the model here. So from sklearn, right? Dot linear model. So we want to what? Import Also, would have done that you import linear regression. Linear regression. This is why I don't want to start with this one, because it's starting very scary. Okay, so I'll now initiate the instance. So linear regression. So anytime I say linear regression, I'll represent it with what? LN or linear model. Okay, linear model, LN. So what do I want to do? I want to fit that model. So this fit the model, what does it simply mean? Run, you remember that regression we stated? Y as a function of X, you know? So here will be what? X train and what? Y train. Can you see that? X train, Y train. That's all. I run my model. What's the objective of NAM analysis? I want to bring out my intercepts. I want to bring out the intercept. So can you see my intercept now? And I want to bring out what? The slope. That's the coefficient. Oh, coefficient. So LM, sorry, LM dot coefficient. And that's it. Do we see how it works now? So this is exactly what we did in Excel. This is exactly what we did in Excel. Okay, so maybe next week when we come, I'll show you how to show it properly, just like you saw it in Excel. But this is how to run what a regression model using Python. Does this make any sense? This figure, does it make any sense?
Yeah.
Does it make sense?
Yeah.
So this is our intercept. This is our first coefficient for which variable is that? Income, house, age, so exactly. So next week when we come, I'll show you how to run just like you did in Excel inside Python. Then we'll also do our forecast or prediction here based on this. All right, ladies and gentlemen, I have another session to join. So let me run.
Thank you, sir.
All right, thank you very much. So continue.
Thank you
All right, thank
very
you.
much.